I recommend you guys watch it. It's really, it's about it's showing you how valuable a data analyst is driving the business strategy. So they hire an analyst, that guy, that this actor in the right side. So he was giving the coach whom to hire from, teams, they buy players, right? So was telling him, okay, buy this player from team X, from team Y, that team is low level, pay more for this to get him, bring that as defense, bring that player as attacker, all these details. And then, he led to the success of that team, which was a surprise. And that coach also was, defending the decisions in the front of the team owners and all these things. It will show you how much, sticking to a good analyst decision was leading the team to success. And nowadays, there is many analytics that's coming from, for example, for the basketball. Do you think when they take time out, take it for nothing? No, they are. Do you think when the coach was saying, with their hand, move to the right, move to the left, actually somebody is giving them advices, live, advices, how to make things, how to shake the team in the game, why when they take time out, when the soccer happens, you see teams sometimes they're losing in the first half in the soccer game, but the second half they flip the score. Why? Because there is somebody, is watching this, making all this analytics to them, and then giving them, 50, in the break between uh, the two halves or the two sessions. They are telling them, okay, change this player, make change, let this guy play instead of that guy. So all these based on analytics right now, and it's analytics competition actually, more than just somebody playing in the field. So, but with that being said, okay, with that being said, see, now you understand how important to grow in a particular field, to grow in healthcare, to grow yourself knowledge, you grow your knowledge in academia, grow your knowledge as a data analyst or data scientist, grow your knowledge in telecom, grow your knowledge in whatever field. Be specific, which means if you get a job in academia, for example, a data analyst academia, don't think it's going to be easy for you to change to a healthcare. Okay, it will be a big barrier for you to go there. You need to find somebody to help you get a data analyst job in healthcare. Then you can start growing yourself in the healthcare data analyst, and find better job also and change jobs over time. But like I said, you have to start with one domain. Now, with that being said, this lead us to know to increase your awareness also with the data format, because data could come from different sources, could come from different formats, could come from different resource systems within the company. For example, in 2019, I was working with a transportation company, and that was my first time working with a transportation company. I have no idea what the data looks like in a transportation field. But when I was working with them, I started to realize, okay, the data that's coming, I try to familiarize myself. For example, they use at that time, they used to have 35 sensors installed in the trucks and trailers. You see the trucks and trailers in the road that carry, for example, products to Walmart, carry from one location to another location. Each truck and trailer has at least 35 sensors. What are these sensors for? Every wheel has a pressure sensor. That pressure sensor is sending a data to a machine installed in that truck, and that machine is sending the data to the company. So they know live, okay, with live data, they know which the air pressure in all these in all the wheels in that truck. They know the weather, okay, the weather data that surround that truck. At that time, because they are collecting this data, I remember, they used to have, I can give you the company name even, and I will show you. Uh, okay, so this is the company I used to work for. It's called Mozilla Valley MVT, Mozilla Valley Transportation. Those guys, because of the sensors, they came up see, they have more than 6,000 trucks and trailer, and each a trailer, sorry, and 1,600 trucks. Each one of these, it has 35 sensor installed at that time, and 35 sensor. Each one of these sensors send information every 15 minutes. So imagine 7,600, 7,600. Okay, 7,600 multiplied by 35 sensors, multiplied by by yeah, I need to do the calculation how many 15 minutes a day we have. So imagine 10, just for sake of simplicity. Imagine we have 10, 15 minutes period. So 10 multiplied by 6,600 multiplied by 35. This is the amount of data we are getting every single day from that company. And yeah, with that data, they announced at that time, they made a competition for which or who is the driver who are driving with a driver score. So they have a driver score, which is the how many. So they are computing the gas consumption per per mile. So for example, that truck or that driver is consuming, let's say, maybe 2 gallon per mile to move the truck. So whoever the truck, Alishan, please mute yourself. So any driver who drive sorry, any driver who uses less gas or less gallons of gas per mile win the competition. And when at that time they used to have a price which was Nissan, I forget the small one, which is La Sentra. What is the Nissan car brands? There's a Nissan. I remember they used to give this car, Nissan Sentra. Not Sentra, what's called? Oh, let me find the name. Nissan Versa. Sentra, yeah, there's this one. Sentra, this one. Sentra with S. Yeah, this one. I was looking with C. Yeah, this car. Nissan, it's called Nissan Sentra. Yeah. This was monthly price for a driver who drive more miles per gallon, who drives more miles per gallon. But the question, how they know more miles per gallon? It could be unfair for a driver who's driving, uphill versus driver who's going, downhill. That's why the 35 sensors were used to collect and, as a factors to make, some intelligent work in the back to find out who is the driver who's driving more miles per gallon, more miles per gallon. See, a data analyst is deciding who is winning the competition. It's not being nice, it's not working more hours. None of them is considered, toward as a factor toward winning the car. It's multiple data. Is the sensors combined with the gas consumptions combined with how many miles you drive. All these factors, all of them is, decides who win the competition. So now the question becomes, okay, where we can find this data? I mentioned last time, we have public data set and then we have company database. So we have actually that company, we have a combination of APIs and company database. We are using the API because who installed the machine that collect the data from the sensors on that truck. There is a company. We hired a vendor who installed a machine for us, and that machine is connected to 35 sensors at that time on that truck or trailer. So that machine is connected through the internet, okay, with the vendor, and the vendor collect the data and send it to us. So we used to use an API to connect to the vendor database, get the data of our trucks and trailers, live data, and save it on our servers. And company database at that time was in the form of the contracts that every truck and trailer are in that time. Okay, so that's what we use. But if for sake of learning purposes, there is plenty of public data set that you can use. Data collection and preparation in general. If you don't have this or that, I mean, even within a company database or how they collected the public data set, definitely there are surveys, interviews, observation, experiments, web scraping, all these kind of, methodologies. Data cleaning. Importantly, you have to clean the data, not every single time. Don't take it as religion. I have data, I should clean it. I have data, I should handle missing values. I have data, I should handle missing values. I have data, I should fill the nonce. No, being a domain expert in the data will tell you, okay, is this field in the data should be handled? Should I fill the missing values? Is the methodology that I'm gonna use require complete data set? When we say complete data set, means there is no missing value. Keep in your mind this terminology. Complete data set means all the fields in the data are filled with values. None of them is missing. Knowing the correct, identifying and correcting errors. Tell me, if you are not a domain expert, how you can know that this data point is an outlier or that data point is not an outlier? You cannot know. So you should be, gain more knowledge. Even if you pick up a project for this course, let's say, which we will have a project. Okay, it will have a project. If you have a project for this, you are working on a project for this course, don't use the data blindly. Research what the data means. That's why when you go to a public data set and find them, I'll show you some resources here, you will find that they are trying to define every single column in the data set, every single feature in the data set. Why? Because they want to help you as a data analyst to identify which values are correct and which values are not correct. Help you confirm, if you find outliers using any methodology, is this value, even though the algorithm caught it, is it an outlier for sure or no? Okay, and so on. And we have another problem that comes with the data sometimes, which is called inconsistency. Inconsistency. What does it mean? Imagine you have a country as a field in the database. If you find that the value sometimes as USA and the values sometimes could appear in the form of United States of America. See, sometimes USA, sometimes United States of America. This called inconsistency. This called inconsistency. They don't have unique format. Um, these are the sources. Take a look to them, check them. You need them later in the course. Um, Data exploration. Okay, I got the data. Now I'm good. I went to the public source. I get the data, or I work in a company. I get access to the data. Fine. What should I do? So in the data exploration, every data analyst project or data science project starts with exploring the data. What does it mean? Make some visualization. Learn about the fields. Learn about the acceptable value for each field. Okay. So for what does it mean, acceptable values? Imagine if you have a country as a field in the database. Is it acceptable to have Sugarland as a country? No, Sugarland is not a country, it's a city. So that's how you know, okay, if acceptable value is there or not. Practice or build visualization to show you patterns, build visualization to show you outliers, build visualization to show you trends. Okay, so these kind of things that you need to be aware of. So data exploration, people usually refer to it in the companies as EDA, okay, as EDA. So the EDA starts by, okay, load the data, inspect the data. How you inspect the data? Just make a quick look at the data. Are you going to check the data, going to the file, open it, go over 1 million observation? Definitely no. So you need to, in Python, there's techniques where you can print the missing values or how many number of missing values in each field. You can check if the data has duplicates. You can check if the data has inconsistencies. There is methods in Python or R that can help you check the duplicates. There's some commands that can help you check for inconsistencies. It's your responsibility. I'm telling you right now, we will not, write code in these slides, to show you how to do this. Just Google them, you will find them. That's what I'm recommending you to start practicing with the data set to you know to implement these things so you have familiarity with it. So once it comes to the project, you will not have difficulty, doing stuff. And maybe in some of the homework, you will be asked to do this. So I'm gonna ask you maybe in one of the homework, okay, check for duplicate. Is the data have duplicates or what? So you have to be able to answer this question. How you answer it? Through code, not visual inspection. Also, there is ways in Python where you can print, descriptive statistics. There is ways in Python where you can print you the mean, the median, the standard deviation, all these things, If you have, this is about numerical data. If the data comes in the form of categorical variables or features, like what? Like, for example, what is it? Like, gender, could be the country. So these string values, okay, string features, you need to, for them, how you explore them, print the frequency. How many people, how many students we have from, for example, Turkey? How many students we have from India? How many students we have from Jordan? How many students we have from United States? So these kind of frequencies we're talking about. Distribution, proportions, you print percentages. Identify, potential outliers. Outliers and anomaly, they are can be found in the numerical features. Okay, so don't try to use categorical features. So knowing these rules is crucial for you to build a summary statistics for the data you have. Okay, continuing with EDA, create visualizations. Plenty of visualization you should create. I mean, these visualizations should vary. Could be a histogram, could be bar chart, could be scatter plot, could be, interactive visualization. There is, in Power BI, there is interactive visualization where you can interact with the visualization. It's not just a static or just a picture that you build or you generate from a code. With visualization also, and try to make it, I mean, there is univariate visualization, there is multivariate visualization, there is bivariate visualization. Try to have a mix of all these things. When I say try to have, I'm not saying just, to build up tons of visualizations and they say, hey, okay, these are my visualization. No, you create them, you read them, you interpret them. Once you think a visualization out of all, let's say you build 100 plot, look at them, read them. If any of them tell a story, if any of them show a peak in the data, or if any of them show something important or deliver a message, you share it with your audience. If I am your manager and you work for me, I'm expecting you to develop 100 visualization. Just I'm throwing a random number. But I'm expecting you to present to me 10 of them only. You cannot create just visualizations because different colors and that's it. No, a visualization should have a story to tell. Feature engineering. Once you finish the visualization, once you create these things, you might need to do some feature engineering. What do we mean by feature engineering? When sometimes, if you talk, let's say, we have a survey that collects the income of people live in a 3 neighborhoods. People could have their income more than 250K a year. In the same neighborhood, we could find people whose income less than 60K. When you try to plot them, you might find that, you have ugly plot, something like this. You can see you have point here and then you have points here. Let me show you here. So you could have point here where the rest is in the middle. So this is ugly, okay? And you cannot tell, for example, for the orange one, what is what is the exact number. What you can do some feature engineering on the top of this. You can do transformation for that big range. So when you have a big range or big gap between the maximum and the minimum of a particular numerical field, it's advisable to use transformation to bring it down to a shorter range. So for example, if my data ranges from 0 to 2 million, I cannot have them in a plot, a scatter plot, because to the problem I just show you. So what I can do, I can bring that 0 to 1 million to a range of maybe 1 to 10. You'll see it, But again, it's optional. If you see a problem visualizing the data, think about transformation. It's good also to do some binning. It's good to create, ranges. So for example, if you have age ranges, let's say, suppose in the data I'm collecting right now, I have the age of every one of you. But also it's good to have maybe a new feature. This is called feature engineering. Create a new feature in the top of age. I call it age group. So 0 to 18, one group. 18 or 19 to 30 is a second group. And then I can, add yes or no in that field, just to reflect that. For example, Zaid is in group of maybe 25 to, or sorry, 19 to 30, maybe Salim in the age group from 30 to 40, something like this. Okay, so this is called feature engineering. It could be a better way, to represent the data using the age group, other than better than just, plotting the age by itself. Data cleaning, again, handle missing values. How you handle them? There is plenty of method. You could use mean, median, mood, or more sophisticated methods, as we'll talk about them later in this course. Address outliers. It's good to show the outliers. If there's outliers in the data, it's good to show the people, you know, what are the outliers. You could, most people sometimes, like, for example, for myself, when I deal with outliers, I like, to try to remove them, or test my work with them and without them. Okay, because it's good. Sometimes the outliers could be very legitimate observations, so you cannot just go with removing them all the time. Okay. Encoding the categorical variables. This is needed when you build a data science work, I mean machine learning model, as we will see later in the course. Hypothesis testing. There is plenty of methods in statistics where you can do hypothesis testing, like t-test. It's one of the methodologies that's used to test a hypothesis. What does it mean, a hypothesis? For example, I have males and females in the students in the class, and I want to test and to make, to evaluate if the males performance in the homework assignments is better than the females. By looking at the data, I make a guess. Okay, I'm thinking, the females' performance in the homework is better than the male students. So to validate this, I will try to find, a statistical method to help me test my hypothesis, which is, like I said, I'm guessing the females will do better, or did better than the males in the homework, whatever that homework is. Now, a small population, you can't just look at them, but if it's, a population in millions, you need to have a methodology that can help you do the hypothesis testing. Uh, EDA, what should I do with the EDA? Well, documentation, what you did, why you did it, what is the question that you try to answer. Okay, so when you build a univariate, let's say when you build a histogram, what was your intention? Document that. Okay, in your EDA, you have to identify the key trends, the patterns that you're seeing. For example, I saw, okay, maybe I could be a pattern. Honestly, that happens to me in the past. When and this is why, for example, right now I'm having my assignments due date, all of them in the weekend, because in the past I was noticing, if the assignment due date is within the week, I have more late submissions, and less grades. If it's within the weekend, I'm getting, almost full submission, minimal late submission, and better grades. So that's why I changed. So this is called a trend. I find a pattern that's happening, or a trend. If it is the mid of the week, bad grades, weekend, good grade. So I identify there is a seasonality in the data. This is called seasonality, which is which I mean seasonality could be a day of the week, make it a different from the other day, or a week versus other week, could be a month versus other month, could be a holiday season for versus the rest of the year. Okay, so that's what should be in the outcome of the EDA. You should be able to identify, the next steps. Never finish your presentation saying, okay, thank you, that's it. No, you should say, given all the findings that I have, this will happen next. Okay, always show that you are planning ahead. Tools, what I can use to build the ETA. I could use Python, very popular, different visualization libraries from Python. notebooks. You could install Anaconda. You can in Anaconda you have Jupyter notebooks. You can use Colab. It's free from Google with a Google account. Any of these could work. In this slide, or R, it's up to you. For the rest of the slides, I will talk about little bits about some R functions. So in R, I'm not saying to use R. It's up to you. Use R, use Python in the future homework. It's up to you. But just to show you here very quick, there is some functions in R. For example, me personally, I prefer to use R sometimes, but not all the time. I prefer to use Python and sometimes, not all the time. So for me, if I have the choice to choose which one, I will use Python for EDA and visualization. I will use R for doing, for example, modeling, linear regression, XGBoost or whatever. I prefer R. I prefer Python for visualization and dealing with the data and so on. In R, there is plenty of functions. I'm just bringing this. There is, for example, a histogram function, and that's it. Okay, there's a histogram function. You can just run it against one of the fields, and you will see a plot of a histogram. There is bivariate graph or bivariate plot. What does it mean? It's an XY. When you have a plot that says XY, see this is XY, so X and Y, this is called bivariate. Okay. This is when we need the bivariate is if we want to understand the relationship between X and Y. Is the relationship showing, for example, increasing pattern or decreasing pattern? In this case, for example, I see if the total sales from whatever is increasing, total sales from the other thing is increasing. So the bivariate analysis in different format could be a linear, could be line, could be scatter plot. Either way, it's going to show you the relationship between X and Y. So we focus on bivariate plots where each point represent a joint observation. Why joint observation? Because we're saying X value, comma, Y value. Yeah. If it is this way, there is a relation. If it's this way, there is the relation. If it is a steady, there is the relation. But if it is, random, there is no pattern that's there. It's not showing me any correlation. If these points, you can see this point could be an outlier. Okay, by this visualization, it's showing you, where you dig deeper. Types of bivariate plot, you could have, categorical versus categorical. You could have a plot categorical versus quantitative. How? For example, let me show you here. So for example, suppose you want to have a plot that show you uh, uh, you know, uh, car brands, okay, car brands, and you know, um, color. So color is so this so you can have a bivariate plot that show you again the relationship between the car brands and the colors. Okay, so that could be a case. You could have a categorical and quantitative, which means I want to see how many cars of different colors I have in a particular neighborhood. Quantitative and quantitative could be, like I said, month versus sales. Could be, for example, age versus grade or versus salary. And you can see here, there's three examples where the first one is categorical versus categorical. This could be categorical versus quantitative, where it has a categorical feature and a numerical feature. And then we have number versus number in both X and Y. So start to familiarize yourself with these plots. Communicating density in the plot, okay? Sometimes instead of, traditional plot, we can produce what's known, sunflower plot. I don't know if you guys seen sunflower. It's in the page 64, page 60, 97, sorry, of the book. But let me show you the sunflower on the side. I'll show this. Yeah. So sunflower is something like this. So it is showing you, these are one of, I mean, it's not the only plot in the world, but it's showing you, for example, that this point, let's just highlight maybe this one. So this is what? This is looks like 250 in X, 250 with 20. So with this, with more petals, okay, this flower with more petals, it is telling us that there is too many data points in the data set that has the same value, 250 with 20. For example, just to make it easy, so start with this. So this one is 1 point. This one is 1 point. I have, let's say, maybe it looks like 230 with like maybe 29. So 230, 29 is only 1 point in my data. But this is with sunflower, I can't tell. With this point, for example, in the middle, in the center, the point in the center is the real point. So in the center, it looks like, I have 1 point, sorry, I have 3 data points, 1, 2, 3, with the same value. So it looks like 420 with 13. So for 2013, I have 3 data points. But this one looks like this is the most popular one in the data, like 250 with 20. So that's a sunflower. So like I said, don't skip over these terminologies. It's this slide is very rich with terminologies. So please go over the concepts, and read about them more. Bubble chart. You guys have seen the bubble chart, or can show you the density. If you have a small bubble, it means, less data points of that point, can see. Sometimes people use it for food, country. If this one represents highest number of borrowers. So you can see, more borrowers from the food versus retail versus art, you know. So that's kind of, show you. Sometimes people use it to show the distribution of people from different countries. So maybe we have more people from from America. So we'll see this big bubble. Let's say we have maybe one student from maybe Syria. So we'll have 1 point. Let's say we have 15. So it's students from Turkey. So we'll have more bigger point for Turkey versus, for example, Syria. Maybe we have 10 students from Pakistan, so we'll see different size bubble. So the size indicate the density. Okay. Sample use cases. You could use plots not just to do visualization, as I said, as we said before, to find the trends. It could show you, to use it to assess normality. So why I'm bringing this, even though it looks like just a normal plot, okay, or a plot, but it could be used to assess what's called normality. So why we need to understand normality? So if you remember, I mean, if you know it before, or I mean, maybe you didn't see it before, but I'm just saying, sometimes there might be a question that says, okay, I want to check if my data has a normal distribution. Okay, why I need to check the data if it has normal distribution? Because this means the data, has enough coverage from everything I want in that data, whether age groups or whatever. So how I check the normality? Normal QQ plot is a plot that can be generated in R or Python, okay, and this is gonna tell you if that feature has a normal distribution or no. If it is normal distribution, you see this solid line in the back. If all the data points are on the solid line, this means that you have perfect normal distribution. If the points are in the tails are going this way or going this way, this means you don't have a normal or perfect normal distribution. This is where the transformation I mentioned earlier comes to play. We could make transformation and regenerate the normal QQ plot to have and check the distribution for the transformed data points. If yes, then we can proceed with the transformed data points, because they are close to perfect normal distribution versus the original data points. Now the question, okay, why I care if it's normal distribution or not normal distribution? You care because, for example, if you want to build a linear regression model, one of the assumptions for linear regression model is that the linear regression model assumes that the data is normal, which means if you feed it with not normal or abnormal data or abnormal distribution, the model could give you wrong results. Okay, so to trust the model output, you should have a normal data or normally distributed data. Okay, how to check the normal distribution? QQ plot. One way. You could use the histogram. You could use, the density plot. So there is plenty of, but QQ plot is popular method or popular plot for assessing the distribution. Finally, like I said, the books are in GitHub. There's this link is really good one to take a look to, different plots. It will show you in chapter 3, 4, 5 or 4, 5, 6, sorry, different types with different examples. And like I said, at least there will be a quiz and a homework. And some homework question, like I said, it will be describe a plot or build a plot. Building plots only using code, okay? Describing plot, and don't forget, every plot you develop, you should provide a description of the trend or what you see as a fact or what we learn from that plot. Don't give me empty plots, plots without description, without description. And that's all I have for today. So again, expect a quiz, expect homework. I will, these two things are for minimum, you will see them. Let me think about the discussion, what I could uh, give you, or I could have the question, as part of the homework. But yeah, minimum quiz, minimum one quiz and one homework. Homework could be worked as a solved as a group. Group could be up to 3 team members. And again, if it is the 3, when I take a look to your solution, I'm expecting better submission versus one student in the group. Okay, it's optional, the group, it's not mandatory. But if you are planned to work in a group, you have to tell me or notify me at least 3 days before the due date. If the due date will be whatever Saturday, that date, then you have to let me know by Wednesday at most. After Wednesday, if you are forming a group, I will consider that as cheating, and both of you will get 0. So, okay. So I just want to make sure you guys, why 3 days? Because I want to make sure you guys at least communicate with each other and talk to each other about the solution. Because forming a group in the last day, it doesn't make sense. Because it means, one of you have solved the homework and the other one just add their name. So any questions before we break? If it's personal question about something that's specific to you, please send me team message. If it is a question about the class, the material, yeah, let me know, or you can ask it in this public discussion. Questions?
Sir, where we can find our homework?
When I post it, it will be in Canvas. It will be in Canvas.
Uh,
Have
okay,
you
okay.
opened Canvas so far?
Yeah, I did.
Yeah, so it will be here. Everything related to the module will be here. So we are in module 1 right now. This is the slides. These are the slides. This is the recording of the last session. I will add date to this one, so just not to confuse the students. And they will add the link to this live session recording here, so you can access it here, or you can access it from Team. I get these questions all the time. How I can access the live session recording? It's going to be in Teams. See, this is the data analysis live session. Last time, it is here. Just go to Teams, to the chat, and open it. You don't need to find it in Canvas. But where the homework will be, it will be under module 1. Okay? Questions? I will be taking attendance starting from today. Last time I didn't take attendance because still students are added to the course. So, yeah. Any questions?
No, sir. Thank you so
Okay.
much.
Thank you so much for joining. And yeah, talk to you in 2 weeks and work hard. Bye bye.
Thank you, sir.
Thank you, Professor.
Yeah, thank you,
Thank
sir.
you so much.